So why would almost everything on Earth die? Marine geochemist Lee Kump thinks he's found the answer. The key is in how big volcanoes could change the environment, including the chemistry of the Permian Ocean. To test his idea, he designed a computer model to simulate the Permian world.
So the model starts out like a weather forecasting model or a climate model. It has the winds, there's the ocean currents that are driven by those winds, there are temperature variations, but the model also has life in it.
All plants and animals and bacteria are in fact chemical factories, taking in nutrients and spewing out waste products. With life's chemistry factored in, Lee's model reveals a disturbing chain of events. It all starts with the Siberian traps, but the trigger is not the incessant flow of lava, which would burn and bury any life nearby. No, the real culprits are the gases that the volcanoes spew into the atmosphere, including one we've all heard of lately, carbon dioxide.
Carbon dioxide that's spewing out of these volcanoes is a greenhouse gas.
Greenhouse gases trap the sun's heat in our atmosphere, forcing the whole Earth to warm up. Of course, that's global warming. But it doesn't end there. Global warming would have heated the Permian Ocean, and when it did, ocean chemistry would have changed dramatically.
There's a difference between warm and cold water. Cold water can hold more gas than can warm water. And so this is fundamentally why we drink champagne and beer and soda cold rather than warm.
What's true for champagne, beer, or soda is also true for the ocean, and one of its most important gases, oxygen.
Cold water can hold a lot of oxygen. Warm water can't hold much oxygen.
And if water loses its oxygen, things can go from bad to worse. Lee and his research team have seen this firsthand at Green Lakes in central New York State.
Hey Rob, you ready?
This lake is narrow and deep, and there's little wind. As a result, the deeper waters have lost their oxygen.
It's safe to swim in this lake as long as you stay above 70 feet.
Below that, the oxygen-free water has attracted a deadly form of bacteria.
There are bacteria that can thrive under those conditions, and those bacteria produce hydrogen sulfide. Hydrogen sulfide is a very toxic substance, and so the deep part of this lake is highly poisonous.
Oh.
It's also bright pink.
There you go.
Hey, thanks. Look at that.
When we bring these samples to the surface, of course, they're rich in hydrogen sulfide. They stink like rotten eggs, and they're poisonous.
Oh, that stinks. Yuck.
The bright pink color comes from another microbe, purple sulfur bacteria, that thrive in hydrogen sulfide.
Look at that.
Bacteria like these can leave chemical traces in ancient rocks. In fact, such traces have been found in some rocks dating to the Permian extinction. For Lee, it's a sign that the Permian Ocean might have resembled this poisonous lake.
This lake is a microcosm of what we think the ocean was like in the late Permian.
According to Lee's computer model, over time the oceans would have become so full of hydrogen sulfide that in some spots the deadly gas would have bubbled right out into the atmosphere, killing millions of creatures, not only in the sea, but also on land. The deadly microbes under suspicion aren't rare. They thrive wherever there's water and no oxygen, as Peter Ward showed me on an ordinary beach at low tide.
Even here, we're on a beach in Seattle, we only have to go down about 2 inches to see sort of the next step in what we think is this extinction mechanism. There, smell that.
Oh, yeah, it smells like rotten eggs.
Rotten eggs.
Yeah,
And this is
yeah.
hydrogen sulfide from bacteria in the sediment. So let's just take those bacteria, put them in the ocean, and have untold tons of them.
Have it run amok.
Everywhere. The oceans are bacterial filled, and they're producing that same nasty rotten egg smell, but in sufficient quantity, not just to kill stuff in the water, but enough goes in the atmosphere to kill land life.
So it burps up this noxious gas.
Big bubbles come out of the oceans, then it will kill off animals and plants.
And so an extinction that began in the ocean works its way to the land.
Exactly. It's horrible.
So, it starts with volcanoes spewing carbon dioxide. Next step, global warming. The oceans heat up and lose their oxygen. Nasty bacteria take over, burping out lots of poisonous gas. End result? Mass extinction. Peter Ward is convinced this was the scenario, not just for the Permian, but for most of the other big extinction events too.
What really looks like a universal way that this has happened is this global warming leading to this terrible gas chamber atmosphere, killing off life in the ocean and land. It's not so much stuff from space that gets you, it's your own planet.
The Nevada rocks offer some support for the idea, at least for the Permian. This whole area was once at the bottom of an ocean, and tests on the rocks have revealed that in the years leading up to the extinction, the deep ocean water here had lost its oxygen. The next step will be to probe these rocks for telltale signs of that nasty bacteria and hydrogen sulfide. Until there's more evidence, the detectives won't all agree that the case is closed. But these experts are convinced that Earth's own environment could be the perpetrator of a mass extinction, whether it's 250 million years ago or right now.
We know for a fact that there have been huge changes in the environment and climate change. That could happen again today. No asteroids required. The Earth is an incredibly dynamic place. Lots happening. We have to understand those changes if we want to survive.
Aloha means hello. Aloha means goodbye. I came to say hello, but it's time to say goodbye. So if I'm ever back again, don't waste the time we have. Just say aloha, aloha.